We are all currently riding a massive, perfectly balanced engine. Right now, at the equator, you are hurtling through space at over 1,000 miles per hour. But imagine if the planet hit the brakes. The bedrock locks into place, but because of inertia, everything resting on top of it keeps moving. The atmosphere instantly transforms into a supersonic shockwave. Winds exceeding 1,000 miles an hour would tear through cities, completely leveling skyscrapers. Because they aren't bolted directly to the Earth's crust, cars, infrastructure, people, and even the oceans themselves are violently ejected sideways. We take this constant motion for granted. The moment we lose that forward momentum, our environment becomes a deadly weapon. And the destruction doesn't stop at the surface. Think about the unimaginable kinetic energy required to stop a planet-sized mass. That force has to go somewhere. The braking pressure slams directly into the tectonic plates, causing the Earth's crust to buckle and shatter out of alignment. This triggers global mega-earthquakes, generating tremors that dwarf the highest magnitudes ever recorded and turning entire mountain ranges into rubble. Even if you survive the atmospheric blast, the ground beneath your feet would tear itself apart. The physical stability of our world relies entirely on its continuous spin. The planet's rotation creates centrifugal force, pushing ocean water outward into a massive equatorial bulge. But when the spin stops, gravity takes over, pulling that colossal volume of water straight toward the North and South poles. This creates a catastrophic global flood. Entire northern territories are swallowed whole, submerging places like northern Europe under miles of rising tides. The surge pushes deep inland, drowning vast portions of the Russian landmass and wiping out historic cities in a matter of hours. Back at the equator, the opposite happens. The retreating water exposes the ocean floor, revealing deep canyons and creating a single continuous megacontinent circling Earth. Every continent and sea we recognize on our maps exists in those exact shapes purely because of rotational physics. The atmosphere behaves exactly like the oceans. All that air gets pulled away from the center of the Earth and pools heavily at the poles. That leaves the new equatorial megacontinent effectively airless. Standing at sea level there would feel exactly like trying to catch your breath at the summit of Mount Everest. And down below the crust, the situation is even worse. The Earth's rotation acts as an internal engine, churning liquid metal in the core to generate our magnetic field. Without that churning motion, the dynamo shuts down. Our invisible shield flickers and dies, exposing the entire planet to the harsh vacuum of space. Raw solar radiation blasts the surface directly. It fries every satellite in orbit, wiping out global communication and GPS networks instantly. We'd also lose our concept of time. The day and night cycle would no longer depend on the Earth turning. Instead, a single day would last exactly 1 full year as the planet slowly orbits the sun. We lose our physical protection from the cosmos, our breathable air, and our temperature regulation. The Earth becomes a barren, hostile wasteland. The side of the planet directly facing the sun now endures 6 continuous months of blistering, ocean-evaporating heat. On the dark side, temperatures plummet into a permanent 6-month winter, getting unspeakably cold, so cold that the remaining atmosphere could freeze and fall as liquid nitrogen rain. The only place you could survive is a narrow sliver of land called the twilight zone. It's the exact border where the freezing dark meets the burning light, offering a brief window of tolerable temperatures. But that border is always moving. To stay alive, human civilization would have to build massive, crawling robotic cities, constantly migrating across the broken landscape to chase the setting sun. We would have to abandon the natural world completely, trading a stable home for a desperate life of endless mechanized motion. But let's take a breath and look at the real physics. Is the Earth actually losing its spin? Look at this chart mapping the Earth's deceleration over time. Through a process called tidal friction, the moon's gravity pulls on our oceans, and that drag is indeed slowing the planet down. However, the rate is incredibly slow. It will take billions of years for the Earth to completely lose its rotational momentum naturally. So for now, we are entirely safe. But the next time you feel a gentle breeze or look at a map of the continents, remember that everything we know is a profound gift of planetary rotation.